G'day there, you're watching the Aussie BIM Guru, and today we're going through my first Grasshopper tutorial, which covers sun hour analysis using Grasshopper and Ladybug. So this is part 1 where we'll look at setting up the study, and in part 2 we'll set up our results analysis. So this is my first tutorial, so try to go easy on me in the comments. I might make a few mistakes or just do things that maybe aren't the most efficient method. I've just started learning Grasshopper, but this was the first script that I focused on learning, so I think it's a really important one. It's important to note that I've already done this in Revit and Dynamo, but Grasshopper is a far more efficient method of achieving this. So originally in Revit, what I did is I baked some sensors into the model, and I received some vectors for the sun at certain times of the day, and essentially analyze which ones are receiving sunlight. So sun hours are essentially a requirement in a lot of countries, especially for apartments, where you need to prove that certain areas of your building receive at least a certain number of hours of direct sunlight during a particular day. So typically we focus on the worst day of the year when the sun is at its lowest, in Sydney for example. So this is a great way to test that. So in Revit, what I did originally is actually filtered all the elements in order to override their color, but Grasshopper can do this a lot more directly and inbuilt into a package called Ladybug. So put them up. Grasshopper's definitely going to do a better job. So it's going to look a little bit like this. So essentially, as long as you have some context in Rhino and you have a building to test it upon, we're going to set up basically the ability to generate this study and then also generate these results. So we're using Ladybug, which is essentially a package for Grasshopper that allows us to generate studies based on climate data and also visualize and interact with them in interesting ways. So we're going to be using weather files, so you'll need to download an EPW file from this website, Energy Plus. There are other ways to generate a weather file in Grasshopper, but my preferred method is just to download it and link a file path to it. So Ladybug can actually do a lot of things. This is just one thing it can do. I'm still really impressed at all the tools that are available, but here are just a few off the website that it notes. I'll probably do another video on shadow masks at a later date because that's quite an important tool as well. So you can download it from this link, and essentially you just download for Grasshopper, and it should work in Rhino 5 or Rhino 6. So I'll be using Rhino 5 today, but I think the workflow is pretty much the same in Rhino 6. I will mention B-reps and meshes. So B-reps, or boundary representations, are a type of geometry in Rhino, as are meshes. Meshes are usually better to use for the context in this study, so I will be using meshes for my city, and I'll probably cover at a later data tutorial on how to work between B-reps and meshes. If you have any questions about it, feel free to leave it down below. Anyway, let's actually get started, so enough talking. So what I've got here is just a Rhino model, and essentially I've put things on a few layers. So I have a city model with just a whole bunch of meshes, which represent all the buildings of the city that I'm looking at. And these are a mixture of open and closed meshes in Rhino. So they vary. Each building in this case is just a single mesh because the model that we source in the office I work at comes to us in this manner. You can see that they're quite detailed too. So lots of faces, lots of detail. So Dynamo couldn't handle this, Grasshopper can. I've modeled my building just as a joined set of polysurfaces or B-reps. I essentially just made these using the solid modeling tools. So this is quite a simple element. Obviously you could have a more complicated building form. The important part is that it needs to be one joined B-rep. Essentially it needs to be a closed B-rep as well. So you can see here I've got a closed poly surface as my object type. Anyway, let's actually just open up Grasshopper and get started. So once you install Ladybug and you drag the components onto your Grasshopper dashboard, you'll essentially get this bar here which has all the tools. And we're also just going to be focusing on the sun hour analysis tools today. So the first thing we'll do is actually just drop the Ladybug component onto our canvas. And this essentially lets the bird fly, as they call it. Essentially this loads all the object classes that Ladybug needs to run. I'm also going to drop a component called bifocals, which essentially labels everything with a little tag so you can see what these actually all are. Obviously much better for teaching, but much better for learning as well. It's important to note too that I've currently got icons on and I've also got full names on. So you can turn off full names just to get a shorthand, but I prefer to have the long names on for teaching. Likewise, you can change icon into name, but I prefer icons because when you combine them with bifocals, it's really easy to see what you're dealing with. So typically I just put these up the top. Okay, so the first thing we're going to do is get our EPW file. So we need to import EPW. So we're going to use Ladybug import EPW. As you can see, it's a pretty big node already. It gets a lot of information, but all we really want is a file path to our EPW file. So I'm just going to create a file path, and I'm going to link or set one file path by right clicking on this, and I'm going to be linking to my EPW file that I've downloaded. So I'll open that, connect this, and immediately our weather file data is loaded. So each of these represents a different output that we can gain from this. In this case, we only really care about one output, which is our location in this case, I believe. Yeah, so that's really all we care about, because what we're going to be doing now is getting a sun path from Ladybug. I might need to get it there. Yep, there we go. So again, it's a very big node. There's a lot of components, but we're only really focusing on a few. So we need our location data first. So we're going to connect our location, but there's a few more things that we need to connect after this as well. So we need to connect our analysis period and our time step. So essentially this is the intervals that we're testing at and the range of times we're testing for. So we're going to need an analysis period to do this. So we're going to search for Ladybug analysis period. And essentially this lets us build up a range of days. So it essentially just specifies from and to for month, day, and hour. I'm going to do a time range for a fixed day on a fixed month of the year. So we'll get a number slider, and you can use the syntax for number sliders. So we're going to go from month 1, and we'll go to June, which is the month that we typically test for this sort of study, up to 12. So that syntax will give me a number slider between 1 and 12 set to 6. So really helpful, much faster than going edit. So we're going to go from month and to month are the same. For day, we'll go 1, and we'll default to 22nd, up to 31. And again, we'll make our from day to day the same. And the only thing we're testing a range for is our time. You can obviously rename these as well if you want. So you can make this month, and you can right click and make this day. So for time, we'll do 1, and we'll go to 9 by default, up to 23 for our hour from. So right click, hour from. So we're testing from 9 o'clock until 3 o'clock. Note that for 24-hour time, we'll need to use 24-hour time, so 3 o'clock is 15, not 3. So that'll be our 2 hour. So essentially from this, we should be able to generate an analysis period. We can use a panel to have a look at these if we want, just to see what we're dealing with. So you can see that we're generating 6, 9, 15. At the moment, I think that should build up our analysis period. I'll just double check. No data, analysis period. So that's our range at the moment. So if I connect my analysis period up to here, that essentially feeds in my analysis to my sun path. From there, we also need a time step. So that's basically going to be the breakdown of how many intervals we divide our hour by. We can make probably another slider, and we'll just make this between 0 and 5. We'll set it to 4 up to 15. So at the moment, it's going to be broken down into quarters. So I'm going to set my time step to 4. So in this case, I'll just call this time step, and I need to feed this down here into my time step on my analysis period. So essentially that sets up our analysis period to be tested. And from this, all we really care about is our sun vectors, because these are going to feed into our sunlight hours analysis. So we're going to generate a sunlight hour analysis. And on the Ladybug tab, you can actually access this, I believe, here. So all these things are possible to find on the ribbon. If you ever need to know where to find something, I think you can hold Control, Alt, and click, and you'll see that it'll navigate. Sometimes it won't find the right ones for custom ones. It'll tell you that it's a Python script. Other times it will. In this case, it's not telling us. It's telling us that this is a Python script. So what I'll do is I need to connect a few things up here in this case. So this is where we're going to go and get our geometry. So I need to get a brep for my building, and I need to get a set of meshes for my context. So at the moment, it's important to note that I've just put these on different layers just to make them easier to select. If there were other elements like terrain, etc., I recommend putting them on a separate layer you can turn off. So for example, I do have a terrain here as a mesh as well, but I've put it on a layer that I can turn off so that I don't select it. So at the moment, we're going to set our building as our B-rep and the buildings that we care about as our meshes. So north is this way in my study, because I'm in the southern hemisphere. I only really care about buildings roughly in this zone of my site, because I know that buildings behind my building aren't going to really get in the way of any shadows. So I'm going to set my B-rep first. So I'm going to right click and go set one B-rep, zoom in, get my building. I'm going to set multiple meshes for my context, and I'm just going to drag roughly that amount there. And it's already processed all those meshes, so very quick. It's important to note that I'm working in meters. I've tried working in millimeters. I find that it gets a lot slower if you don't work in meters. So be careful with your units in Ladybug, because I found that some don't seem to work as well as others. So what we need to do now is create our context, because we have our geometry for our building and our context that's going to clash with the sun. It's important to note that you need to make sure that your building is also included in your context, because the building gets in the way of itself technically. So we're going to use a merge list in order to join our B-rep to our mesh. And it's important to note as well that all of our incoming data is being flattened by default. So we can feed in this list even though it's got two sublists that are being merged, because it's essentially going to flatten all these elements into our context. As well as that, we can take our B-rep and feed that into our geometry. So I can just clean this up a little bit. We'll clean up all these inputs in our second part. There's a couple of other elements we need to feed in as well. So one is our grid size, the other is our distance from our test surfaces. So we're going to make a number slider, and we'll just go between 0. We'll set our default to 3 meters to 3 decimal places, up to a spacing of 10 meters. Whoops. And I'll just change the rounding by going to edit, rounding, and we'll just make it 3 decimal places. So by default, this is the spacing of the grid. So I'm going to test at samples of approximately 3 meters by 3 meters. So this is my grid size. And then I'll feed in my distance from base as well. For this one, I'll just do 0, 0.5 up to 1. And this is essentially how far off your surface you want to test, because you can't put your test points on your surface, otherwise they clash with the building, and you can't get any sun rays. So as you find, about half a meter or so is probably enough to know that you're still getting fairly accurate results. So that's pretty much set up at this point. We can call this, obviously, distance from face, and we can call this sample size or grid size, whatever you want to call it. At this point as well, really all we need to do now is run. We could also add a slider for north. So at the moment my Rhino model is set so that north is north in Rhino as well. If you're working at a rotation angle, you can actually set up another slider to deal with this. So you can go between 0, we can start at 0 here and go up to 360, and obviously you can add decimal places to that as well, so you can go round to 3 decimals and feed that in as well. And we can obviously make this a north angle or north rotation. So essentially this is a clockwise rotation to your model to apply to the study. This is how you can get around not having to rotate your entire Rhino model to deal with a north rotation. Okay, so essentially all we need to do now is run and potentially bake our values as well. So we could use a Boolean toggle. So if you search for bool and you find Boolean toggle, you basically, once you turn this on to true, when it's connected to the parameter run it will run the study. But you may not want to do that, because what happens is the next time someone opens the script, it will run straight away. So a really good way around this is actually to use a special Boolean toggle. So I'll just wait till my autosave is finished. Good time to autosave. Okay, so there's a special Boolean toggle here called a false start toggle. So essentially, when a document opens or a script opens with these, they will always start off as false, whereas these will start off as the last thing you left them as. So I really like these because it stops your script from running immediately. So we're going to use this one for run it, and we'll also have one for bake it as well. So baking, for those that don't know what that means, is to actually put the results into Grasshopper, into Rhino as geometry rather than geometry preview. So we'll just go to run it and debake it. And I'll just connect these down. Currently they're false. And what I'm going to do with these is just right click here and change the wire display to hidden. That way they don't get in the way of my script. And you can actually do this with a lot of your inputs to keep them closer together if it's easier. Note that you can still see the wire by selecting the node, but until you actually click on it, you won't see it. So that can be a great way to clean up your script. And essentially this can be a really good way to keep all your results and your inputs in one place. So for example, my EPW file, I could do the same thing, and I could just move this up here. And then I might just quickly just tidy up some of my results here. So let's just group some of these together. Cool, so there's some inputs, and there's some of my inputs up here as well. Cool, so that's pretty much all my inputs really clearly identified. At this point we need to feed in our sun vectors, and also our time step, I believe. Yes, so we also need to connect our time step here. So we're going to go back to our time step and plug that in here, and I might just hide the wire as well so it's not in the way. And essentially we should be able to run our study now. It's important to note that you might want to turn off your actual Rhino geometry, because you can see the preview geometry instead. So if I just turn this off, you'll see now we can see all of our test geometry. Note that we probably don't want to see our BREP. So what I might do is I might just hide some of these inputs as well. So I might hide my BREP, and I might hide my merged list. So I still see my context as geometry preview. Okay, so let's run our study. So all we need to do now is double click on run it, and this should begin to run our sun hour analysis. And there it is. That's how quick it was. So let's see what the study's actually done. So it's obviously representing the sun hours received across the day using color. And you can see the samples sort of broken down here roughly. So depending on the size of your building, you might want to change your sample size. It's also important to note that every single face has had the study run upon, even the bottom of the building. So we're going to look at that in our second part, how to filter out some of those results that aren't relevant, because we never test obviously the bottom of our building, because of course it receives no sun hours and no one has any windows on the bottom of the building. So why would we care? But it's also important to note we've got our legend here, and this is why the time step is really important, because if you don't feed the time step in here, you'll get an inaccurate number for the total number of samples received. So that's why the time step is critical. This way it knows how many hours it's dealing with in the number of successful vectors that it's clashed. One thing that's a little bit hard to get used to with this study is that you don't see all the results. You don't see all the vectors and all the lines and all the points. However, one of the great things in Ladybug is that all of these outcomes can be viewed here. So you have all your test points technically. So I can actually look at all my test points by feeding in a point node to test points. And if I zoom in here, I'll actually see all my test points. So we're going to use these in our second part in order to omit the points that occur on faces of the building we don't want to test, such as flat surfaces. So that it's really great. There's a lot of ways you can view the results of your study. By default, these aren't previewed, so you will need to feed them across to see them. Interesting things that you can see. As well as that, it's important to note that we have our sun hour results by our test point. So this is where you can see our total number of sun hours. So we're going to process these in the second part as well in order to find out on average what our sun results are telling us in number format. So really important that there's a lot of things we can see there. Beyond that, we can also bake our results into the model. So if I do bake this and go true, we should expect to see this become a part of our model. So if I just go here and turn on my test model, it should actually bake into my model. It looks like it may not be on my current layer. Here we go. So it bakes it into a layer called Ladybug Sunlight Hour Studies, and you can turn on your results in order to see your results. It's obviously a pretty heavy mesh, so it may not be worth baking this into the model. I never do. I just visualize my result and process the data. So we'll just delete that and remove our layer. So yeah, something this heavy, probably not worth baking. But that's pretty much all for this video. That just shows you how to undertake a basic study and how to establish an analysis period for your weather file that you're testing. But in the next part, we're going to look at processing these results. So we're going to look at the workflows where we take out or cull irrelevant faces that we don't want to test. We're going to process the tallies of what we're looking at, and then we're going to graph our results and just tidy up the script a little bit so that a user understands how to use it. So we'll look at that in the next part. So thanks for watching today. Hopefully you found that really helpful. I found there's a lot of workflows out there on how to do this, but I didn't find one that sort of went step by step and sort of told me the process without taking too much time but skipping too much at the same time. If you've got any questions or feedback, feel free to leave it down below. Hopefully the next part will finish off the study and we'll show you how you can process your results. If you're not already following and subscribing, feel free to do so. I make videos about 2 to 3 times a week. I'll be focusing on Grasshopper and Rhino as well as Dynamo and Revit for quite a while. So hopefully I'll see you in the next video. Thanks. Take care. Bye.